Okay, we're going to work out the solutions to the regular quiz on friction. Okay, so problem number 1 says, a rope attached to an engine pulls a 240 Newton crate up a 14.7 degree ramp at a constant speed. So we're given that the weight is equal to 240 newtons. The angle of the incline is 14.7 degrees. It's at a constant speed, and I'm going to write that down so I don't forget the acceleration is 0. And then they tell us that mu is equal to 0.32. What is the magnitude of the force that the rope exerts on the crate parallel to the ramp? So we want to find the applied force. So before I do anything else, I need to draw my free body diagram. So here's my object. It's being pulled up with an applied force. Now, I want to be aware that it's moving up the ramp, and I always want my sign convention to go in the direction it's moving, so I'm going to draw my sign convention like this, X, Y, okay. If it's moving up, friction is going to act in the opposite direction. So this is my frictional force. The force of weight always acts down, and the normal force acts perpendicular to the surfaces in contact. Now I want all my forces to go the same as this. So this is my free body diagram. If I was doing an FRQ, that's 1, 2, 3, 4 points, because I have all the forces, I don't have extra forces, and I have them all going in the same direction. But now when I have to sum forces, they have to go either perpendicular or parallel to the surfaces in contact. Well, the weight doesn't, so I'm going to take my weight, Fg, which is 240, and I'm going to break it up into horizontal and vertical components that act perpendicular. So we'll call this Fgy, this is Fgx, this is my angle, which these are similar triangles. So Fgx is equal to Fg sine of theta, which is equal to 240 times the sine of 14.7. So Fgx comes out to be 61 newtons. Fgy is equal to Fg cosine of theta, which is equal to 240 times the cosine of 14.7. So Fgy is equal to 232 newtons. Now, you have to be, the directions of these components is so important, because if you don't draw these the right way, you're going to get the problem wrong. Now, instead of drawing it at an angle, what I'll do now is I'll just kind of shift it so I can kind of look at it this way. And it's the same thing, but this is just going to make it easier for me. I mean, I could still draw it on an angle. So my applied force stays the same. My frictional force stays the same. My normal force stays the same. And then instead of my weight, I'm now replacing it with Fgy, and Fgx is going to go this way. What do I do first? Well, I want to find the applied force, which is going in the x direction. So I know I'm going to have to do that last. So for what I'll do first is I'll sum forces vertically. And I guess I'll just use the same marker. Oh, here's a green one. So when I sum forces vertically, I'm going to say summation of f of y is equal to ma. The block is not even moving that way. Remember, it's moving this way, so it's not even, so this is 0. It's not accelerating. Now, what are the forces going in the y direction? This is where now I look at my free body diagram, and in the y direction, Fn goes up, which is positive, and Fgy goes down as negative, and that's equal to 0. Okay? So Fn is equal to Fgy, which is equal to 232 newtons. Then, the next thing I can do is I can use my mu equation, and I know that mu is equal to f of f over f of n. So so I know that f of f is equal to mu times f of n. So it's equal to 0.32 times 232. So f of f is equal to 70 4 newtons. And then the last thing I have to do is I want to solve for FA, which is x. So I'm going to sum forces in the x direction. Summation of f of x is equal to ma. And it's not accelerating, it's moving at a constant speed, so that's 0. So now when I add up all my forces going in my x direction, I look at my free body diagram. FA is positive, minus f of f, which is negative, minus fgx, and that's equal to 0. So f of a is equal to fgx plus f of f, which would be 61 plus 74. So f of f, fa, is equal to 135 newtons. So that's problem number 1 on the quiz. And that's it. Just like the homework, pretty simple. All right, so let's do the second homework problem. Quiz. This was our friction quiz. So it says a couch with a mass, so I'm given the mass is equal to 1.00 times 10 to the 2 kilograms, is placed on a jumpable ramp. So as it's lifted, it starts to go down. So remember, I don't have to have a push or a pull. I need a harder book. Let's use this. So here, once the angle gets to be a certain angle, it's just going to fall on its own. So the key to this is that there's no applied force. And this is where they'll get you on the AP test, because someone will say, oh, there has to be an applied force, and they put in forces that don't exist. Okay? So we want to find the coefficient of friction. So I'm going to draw this, and this is my block. This is f of f. This is f of n. And this is f of g. Now here, it's moving down. So this is the way it's moving. So this is the way my sign convention is going to be. Okay? And this is 12 degrees. So the first thing I'm going to do is I'm going to take my weight, f of g, and I'm going to break it up into its components. They act head to tail. Remember, they're perpendicular and parallel to the surfaces in contact. So this theta is equal to that theta, 12 degrees. So this one is going to be opposite, which is sine. This one is adjacent, which is cosine. So fgx is equal to 1.00 times 10 to the 2. That's mg times 9.8 times the sine of 12 degrees. Remember, fgx is equal to mg sine of theta. So fgx comes out to be 204. fgy is mg cosine of theta. So fgy is equal to 1.00 times 10 to the 2 times 9.8 times cosine of 12 degrees. So fgy comes out to be 99 newtons. So now I'm going to redraw this. And again, I'm just going to shift it. You can still leave it at an angle. So I have my frictional force stays the same. My normal force stays the same. And instead of the weight, I'm going to have fgy and fgx. Now remember, this way, that's positive. All right? Because that's my sign convention going down. So what I'll do first is I will sum forces vertically. So summation of f of y is equal to ma. This isn't even moving that way, so that's 0. So now in my y direction, I have fn minus fgy is equal to 0. So fn is equal to fgy, which is equal to 959. Then I'll sum forces in the x direction. Summation of f of x is equal to ma. I do have an a now. So instead of this, I'm going to look. So I have, fgx is the positive one, minus f of f. You have to be careful with these signs. So this is positive because that's the direction in which it's accelerating. So you have to be very careful. So fgx minus f of f is equal to ma. So now I'll rearrange the equation and say that f of f, because that's f of f is equal to FGX. I put this on the other side, minus MA. I move that one over. So f of f is equal to FGX, 204, minus M, 1.00 times 10 to the 2, times 0.79 meters per second squared. So f of f comes out to be 125. So the last thing I'm going to do is I'm going to solve for mu. So mu is equal to f of f over f of n, so mu is equal to 125 over 959. The newtons cancel, and this comes out to be 0.13. So pretty much on every single one of these problems, you draw your free body diagram. You make all your components going perpendicular and parallel to the surfaces in contact. And then it depends on the order of what you're finding, but what you're going to do for every problem is you're going to sum forces vertically, you're going to sum forces horizontally, and you're going to use the mu equation. So this is what you're going to do for every single problem.